Welcome to the Design Vault, a show about the past, present, and future of design. The Design Vault is a conversation hosted by Albert Shum and Tamer Abanami, reflecting on iconic products and ideas from the past and rethinking them from new perspectives.
Hey Albert, how you doing?
Good.
Today's episode is about the Speak and Spell.
Yeah, that was a fun and inspiring product.
And we'll get into it. The Speak and Spell was launched by Texas Instruments in 1978. It became a pop culture icon later on. It kept appearing in compositions of famous bands like Kraftwerk, Jean-Michel Jarre, Depeche Mode.
My favorite, OMD.
Oh, yeah, your favorite. You're always, you had your pulse on the
Well,
music.
it's architecture and morality. That's basically, it sums up my view of life.
That is your philosophy for sure. The Speak and Spell was the device of choice to phone home for E.T. in the E.T. film, and where the act of circuit bending was actually happening on the film. We'll get into that later.
Yeah, and hacking, I guess, really kind of became popular.
Totally. So the Speak and Spell deployed a single chip voice synthesizer called the TMC 0280 from Texas Instruments. And speech synthesis data was stored on a pair of 128 kilobit PMOS ROMs. And it was using bubble memory, which is another area that Texas Instruments was
I just know
leading
bubble sort from my interview question. That's I've never used it.
I know fuzzy logic, that's about it. And bubble inkjet. Or bubble jet. So at the time it was priced at $50, which in today's currency is about $230. Reissued in 2019, I believe, a vintage edition costs about $20 now. And it has a new voice chip, which sounds a lot more realistic. But we'll get into all that. The inspiration was from a calculator. Engineer Paul Breedlove observed his daughter struggling with spelling drills, and he envisioned a talking calculator for learning. And the project started with a meager budget of $25,000, which in today's currency is probably like $150, something like that. And highlighting resourcefulness and innovation from Texas Instruments. And they were exploiting a few tech breakthroughs at the time. When you started your projects, how did they start? They started kind of small and rapid and cheap, or were they giant projects from the moment they launched?
Oh, wow. That's in the toy industry. This is kind of interesting. I think that there's every year there's this event called the Toy Fair. I don't know if you're familiar. I think it used to happen in the New York Javits Center, and then it was this showcase of wacky inventor ideas, who's coming up with the next new board game, to new products from Hasbro, Mattel, showcasing their next season's products. And it was almost like this Willy Wonka kind of like bizarre. And you see the whole range of products. Is it like these big ambiguous projects where like, wow, we're going to create a whole new way to entertain and learn, and you would have these amazing. I remember like these large scale products that, one that pops to mind. It's companies like Leapfrog really started in the, I think, 80s, 90s to expand on Speak and Spell and really create this whole new category of electronic learning aids. And actually I worked on, and my company worked on this idea of talking books. Was this early use of this technology where by synthesizing voice, you could actually record different chapters of the book. And as you turn the page, it would actually talk. Basically, it's like Audible. It would annotate and talk to you in different character and different voices. So I think whole new categories came out from Speak and Spell, and then create these kind of large scale products to individual inventors who had this technology. And one of the technology I worked on also came from an inventor who had, and you're gonna laugh now. We actually had books, but they had little records. Like we could print like almost like a 3-inch little LP, but instead of the record spinning, we had this device you put on top of it.
Like it looked like a mouse.
It looked like a mouse. And you press the button, it would play what's on the page. So instead of the record spinning, the mouse had this spinning a stylus that would play the track.
So I have a confession. I was a kid. I had one of those things.
Oh, so I worked on variations of that. So
what I would do is I would go into my closet and set up a spaceship apparatus, and I would use the stylus thing. I would put it on something that it wasn't designed for to make liftoff sounds. Like
so you basically
yes. And so white noise.
Yeah, or you'd be like a DJ, I guess, scratching, right? Like,
it was. It took off early with me, but this brings us to kind of this inflection point from moving parts to solid state technology in a lot of these toys and technology and machines. And I think a confluence of circumstances really enabled TI to make this, because I remember at the time when I was growing up, weird robotic toys that came with a library of cassette tapes, and I always found that odd. Well, how is it a robot if I have to open the back of it and change a cassette for it to talk to me every time I want to go on? They were kind of quizzes or educational toys, and so this allowed it to be small. First single chip speech synthesizer, solid state speech circuitry. First single chip speech synthesizer, like we mentioned, the TMC 0280 chip, and later named the TI TM55100. This was the first single chip DSP for speech generation. It used linear predictive coding to synthesize speech, analyzing and storing model of human speech instead of pre-recorded audio. This allowed for smaller and more affordable devices. Circuitry was solid state. There were no pull strings, so you used buttons that were sealed. Had interchangeable game cartridges. Had a VFD display, which was not groundbreaking at the time, but it was part of what made it special.
Well, I think speaking of special, I think what solid state did is obviously it made it more compact, right? It was less complicated, back to like making it simple, and it was all self-contained, and there was like no things you had to plug in. There was no books you had to attach. There was no cartridge. Back to that openness. And I think the design, I think was inspired by the design itself. This design language was very appealing. It made electronics less about like the tech, and was very inviting, from the color to CMF, the playfulness, even the button layout. It's not a QWERTY layout.
Yeah.
Right. Which is like, in some ways, QWERTY is actually very, as we all know the history of QWERTY, right? It wasn't human-centered design. It was designed because of the machine constraints, and I think it made it more approachable, and there was immediacy. Like, you didn't have to read the instruction manual. You should just start typing and pressing the buttons and try and figure it out. I think back to this idea of open and play and making it inviting and simple. I think solid state, a lot of these technology, what at least I saw come through, was it eliminated or removed all those barriers that I talked about previously.
100%. I think we'll get into what makes it iconic. So solid state enabled some of the iconic nature of this device, right? It was small, so it makes this iconic. Let's riff on that. It had this handle, it was small.
It had a gesture.
Right?
Yeah.
Had a handle. It was bright red. It had a keyboard with pops of yellow. What else would be the visual gesture?
Yeah, I think the screen layout, the keyboard layout, I think the graphic elements, I think the round buttons, the contrast, like being able to kind of block out the different zones. I always look at, especially industrial design, it's really, people look at the overall form, that's the part, but it's also this transition, right? I think it's like classic ID school thing. Like if you go back to like how the different elements and what's your first read, second read, what pulls you in is really that bright pop of yellow, that keyboard, and then the display. And you immediately like, oh, it's something that you type or write, and then there's direct feedback on that little display. So that's really what I think, kind of states the visual intent or communicates the form or the function.
In addition to the visual icon that it really is, like you said, the first read is this bright red thing with a handle, rectangle. Second read, you see a hierarchy, right? Input, output, pops of yellow. But then we get into the sound. It actually generates this very iconic synthesized speech that had a personality.
Yeah, in some weird way, it created its own personality. It wasn't mimicking a human. At the same time, it sounded like a version of humanity, I guess. It's not uncanny valley almost. It's like
was it mimicking a human, or maybe it was attempting to mimic a human,
right? But it was constrained by technology because
right.
It didn't have enough bit rate to actually sample a human voice, right?
And that's probably why it took off with a lot of musicians, because it sounded unlike anything. Maybe it sounded like the future. Maybe it sounded dark.
But it also had a texture. I wouldn't say dark. I think
it was gritty.
But back to you, this was a toy meant for children, right? So they assume they probably tried the different voices and what made it appealing. It was in some ways friendly. It wasn't this synthetic robotic overlord that's gonna scare the bejesus out of the kids. It was a voice that sounded almost fun and playful, and I think that's what comes through. It was almost like it's like WALL-E, right? You're fun, or if you go back to that era, it's like Short Circuit movie. This idea of this fun robotic personality that could be your companion.
It really did have a personality. I mean, it's really hard to predict that ahead of time sometimes, but also for designers out there in the field, how many times have you been asked to make something iconic?
Right, and I think this is an era where I think industrial UX design really didn't exist even, and I think the engineers and the designers that worked on it had amazing foresight to actually create a voice that was appealing and attractive and friendly and in some ways jovial almost for children. And I think that's lasted a test of time. So, and I think that's another element of iconic. It has that test of time character to it.
So we have some original recording of the Speak and Spell with us to play. So we just want to make sure we can share that with you, so you understand what we're talking about if you haven't encountered one of those in your life. So I'll go ahead and play some of these sounds. I'll do a countdown of 5 to 0.
5, 4, 3, 2, 1, 0.
Blast off.
But listen to that one.
1.
It's gritty, right?
It's gritty, but it's also got like that resonance, that tone. It's got a certain warmth to it.
My favorite is when it starts saying words that are dark sounding, and you could, how musicians would use them. But here's one.
Danger.
That sounds eerie. Imagine you're in a sci-fi movie and the planet is blowing up, and this is the looping alert.
Yeah.
Danger.
Some iconic sounds was the startup tone, which was this. It also can do letters.
A, B, C, D, E, F, G.
So, I mean, you get the gist of it.
Yeah, and I do wonder, like part of the fun with the Speak and Spell is trying to figure out what it can say.
Yes.
Right? It's. I think this is back to open-ended, and I think that's part of creativity is not following the rules. Like typing sentences because you were instructed to. Just trial and error and trying different things and see if you could kind of bend the technology in some ways to create something new. I think that's always the fun experimentation part of play.
Yeah, totally. And I think what's interesting about the Speak and Spell is the hackability of it. Not only in its use, but also you can go into the hardware and circuit bend it. And some of the ways people have used them to change kind of how it sounds is you could disrupt or distort or make new sounds by placing alligator clips in particular spots on the circuit board. There's ways to create a hold effect in the middle of a word like pony, and we'll go pony, and you can make some really interesting
Yeah, so
stuff.
you're literally modulating or bending the sound. Yeah.
So a lot of stories just look up kind of hacking, circuit bending. There's just a lot of Texas Instruments did not restrict the usage of cartridges by region. Didn't make it a closed device. Didn't invest in closing this device as much.
And I do wonder, like for a product like that, like in some ways, it's precursor to language, right? It is language, and so much of the current wave of technology is about language, and back then, it obviously it was just synthesizing voice. It didn't know the vocabulary was hard coded in some ways, right? It wasn't constructing a vocabulary. And I think now we're seeing like the power of language and the language models.
Totally. And what I think is interesting with the Speak and Spell is the design of the interaction was done according to educational principles or psychological principles, mostly guided by B.F. Skinner, who was a leading psychologist of that era. And there were some theories of learning that were applied. Really around kind of how you create an interaction for learning.
Yeah, what were the core principles of that work?
Skinner's theory of learning, I think, is based on something called operant conditioning, and so he was very much about positive and negative reinforcement.
Yeah, back to like this idea of hacking, like when things don't work, it shouldn't be frustrating, right? Like when you're trying to type in certain things in the Speak and Spell, and then it doesn't come out what you expect. I think you want to be open enough, or back to that whole idea of positive reinforcement. Be able to kind of make sure that there are successes as much as there are failures, and I think that's always the balance of what they call in at least in gaming called gameplay, right? You want to make sure that learning curve is not too steep.
100%. And when we get into some of the background here, kind of looking at some of the learning theories and philosophies behind this device, B.F. Skinner is credited to inspiring a lot of what went into it. Also, if you look at some of the literature of the time, in 1960, there was a book called Teaching Machines and Programmed Learning, a source book by Lumsdaine, who argued that to count as teaching machines, devices must have several properties. First is the continuous active student response is required. Second, a basis is provided for informing the student with minimal delay whether each response is correct or incorrect, leading them directly or indirectly to the correction of their errors. Third, the student proceeds on an individual basis at their own rate. Faster students romping through an instructional sequence very rapidly, or slower students being tutored as necessary, with indefinite patience to meet their needs, right? So that's kind of one side. Another side is this book written in 1988, titled The History of Teaching Machines. Historian of psychology Louis Benjamin writes, a teaching machine is an automatic or self-controlling device that A, presents a unit of information. B.F. Skinner would say new information. B, provides some means for the learner to respond to the information. And C, provides feedback about the correctness of the learner's responses. Now, when we talk about this, a lot of things that you worked on currently or recently, like how you work with intelligence, how users interact with that, those, your teams have developed principles there as well. Can you kind of look at the connection between teaching machines and AI?
Well, to be explicit, I think Gen AI, I think language models, I think really builds on this idea of teaching machines. When you're it is in some ways prompt engineering or prompt design. Like when you're trying to create a conversation-based interface, I think one of the things you want to ensure, I think it ties on that principle, that there's always a response from the system. There's no ambiguity, right? That back to new information is presented. Like, I think that's what Skinner was saying. Like, when you put in a prompt, the system responds to language model, Gen AI, the chatbot, whatever you're doing in your UX, there should be a feedback that comes back and say, hey, here's what I learned from you, and play it back and suggest what's next. I think that's the reinforcement for the back to the end user. Here's the student, and I think sometimes that's it's really missing a lot of. Especially, I see this in customer service chatbots, and why people get frustrated because it seems like the system is not listening to you or doesn't acting to what you. So I think this idea of presenting new information, but also playing it back to you, that we did hear what you were saying, and then responding likewise. I think that's one of the key principles. I think we should really leverage from this era of teaching machines. And so often we always think of technology as this whole new thing, whole new paradigm. Oh wow, we have this thing called Gen AI, and this idea of chat bots. No, it's actually a lot of the principles were already established of how machines interface with humans from the 60s to the 80s. And we really should leverage that learning and build on it.
Yeah, and I think this goes back to the thesis of this series, right? The thesis of this series is really for those who are out there working on the bleeding edge or interested in the bleeding edge, it becomes more impactful to study the arc that led to the bleeding edge, because in a lot of ways there's a lot of foundational thinking that you can build on.
Foundational and evolutionary. I think.
Yes.
I think technology always evolved from something. It never just, I think, miraculously, spontaneously appears.
Aliens show up and they
Right.
give you this thing.
Well,
yeah.
perhaps in the pyramids. But aside from that, I think it's so important to think about what worked and what didn't. Why was Speak and Spell successful? What made it friendly and approachable? What made it iconic? And the idea of this kind of making it open-ended, that's what's so exciting about things like ChatGPT and a lot of the language model. It is open-ended. There is no instructions. You just see a text box, an entry box, a search box, whatever you call it. You just see this little box you can type into. It's eerily similar to the Speak and Spell, right? You think about it, like back to what the UI looks like. And you can do anything, and that's the power. That's so simple. That's why hundreds of millions of people can just jump in and start using it and start exploring. So that's really powerful, that open-ended play. But are people able to learn and build on their experiences? Back to this idea of the teaching machine. How are we teaching our end users, our students here, to use the system and to empower them to do more? I think that's the arc that we're on.
I agree 100%. And I'd be remiss to move forward without mentioning some of the challenges that, a lot of what we talk about is also the challenges that face these products that we talk about. Technology was extremely limited, right? It was expensive. Again, $230 in today's currency, $50 at the time. So you had a marketing challenge. Skeptical audience of parents questioned the educational value of a talking toy. How do you break through that? How do you get through that? Cost constraints. I think the way they had to navigate the cost constraints was pretty interesting. And then there's a competitive angle of establishing this position in a market that was rapidly evolving with cassette tapes and things like that. And I think really the way they navigated those challenges, they focused on core. They really focused on marketing to parents. The design was very user-friendly, if not user-centered in many ways. It was inspired by a real person that was going through a thing. And it was engaging.
It was engaging. Also, I think there's this one really, I don't know, it's an important lesson or something to reflect on. What the Speak and Spell did was also it made the parent participate in the child's learning. In some ways, it was interactive not just for the child or the student, but also for the parent, and allow the parent to be involved and learn together. I think that's a scenario sometimes we always forget. We always assume, like, even today, like in a lot of our UX work, is like, oh, there's this individual that's going to be using it, and and interacting with it. But thinking about that relationship with others, it could be a parent or it could be a friend, like this idea of inside the environment even. I think this idea of, I don't want to call it collaboration, but this idea of like kind of shared experience. I think that's something that's really missing right now in a lot of our Gen AI work. It's a bit isolating, most of technology today, and I'm not going to get into virtual reality, mixed reality, and spatial computing. But I think the more and more we think about shared experiences, I think that's going to be another evolving principle. And you're starting to see that even with ChatGPT, where you could use @mention, where you can start adding other people to your conversation with the language model, with and I think that's where we're going to be heading more towards. And I think the Speak and Spell also kind of highlights that opportunity.
Yeah, 100%. Because I think for me, the Speak and Spell success wasn't just about technology. It was about understanding a target audience and its needs and really obsessing over how to solve that. And I think design's job is to do that. But when you're sometimes in a corporate setting or you have the pressures of a deadline, sometimes we suspend that disbelief and we say, no, it's about the tech. But you've seen this and I've seen this where we will sometimes over-index on the tech at the expense of the user.
Yeah, and I think if the designer can connect back to this conversation we had around BXT, right? The business, the experience, and technology. I think that's when our design work has the most impact. And I think something like Speak and Spell, I think back to like there was like TI wasn't a toy company, and it found this technology, and there was an insight, this forethought of like, wow, how do we use that technology and expand it to a broader audience and create a new business opportunity, a whole new category, and develop a product. I think likewise, I think especially when we think about design the UX, there are going to be UX for Gen AI and a lot of these experiences we're seeing today. There are going to be a lot of tension between the business and experience and the technology, and it's finding that sweet spot. And not to be too obtuse, but like this example, I think with Gen AI today is this idea of how do we ensure that the business growth, like, hey, there's going to be monetization pressure, there's going to be engagement pressure for the design team, and the technology will continue to add new capabilities, so there'll be new features added, and it's going to be more potentially creating more complexity, even though it becomes more powerful. And how do we keep that simple text box, and not going to start seeing like, you're always seeing like tabs over here on ChatGPT, and what do you do with those tabs? Or do you need to organizing those tabs? Is there going to be a hierarchy? Is there going to be like menus? Like, you're going to start seeing that a lot of these challenges for design teams to figure out this really powerful experience. How do you actually grow it and nurture it and tend it?
That's a great thought. I think it's a good thought to close on as well. Really, what I appreciate about things like the Speak and Spell is they represent a step along that arc, and how we're able to be inspired by that.
And learn from it.
Right?
Yeah. And I think this series, hopefully for the audience, it's a moment to reflect on these products, but also take it forward, build on it, create new opportunities based on these amazing products that were created. And in some ways, these innovations, right? They're really iconic because they really broke through, and they really create a whole new path for our customers to create new experiences.
Hey, Albert, this was fun. Thanks again for making the time.
Yeah, I really enjoyed reflecting on Speak and Spell. It's such an inspiring, iconic product.
And for everybody who's listening, if think about your experiences with learning machines. Learning machines could be hardware, software, service. I'm using the term loosely. And maybe share anything from your past that was a significant breakthrough in your understanding, breakthrough in your education and learning, or even a giant failure, something that we can learn from in the community and the community can learn from. So thank you, everybody, and tune in to the next episode.
See you all.
Thank you for listening. The Design Vault is brought to you by hosts Albert Shum and Thamer Abanami, and is produced and edited by Romina Hakim, Tonio Telles, and Poonam Patel, with music by Red Lips Media, brand design by Rafael Poloni. Join the conversation on social media at the Design Vault Podcast on Instagram. The views and opinions expressed in this program are those of the speakers and do not necessarily reflect the views or positions of any organizations they represent.